Example 1, solve each triangle, round lengths to the nearest tenth and angles to the nearest degree. And before we even start this, I want to talk about why we can't use law of sines here. You might remember with law of sines, we always needed to have a corresponding side length and angle. Okay? And we had to know them. Okay? And so you can see here, we have angle B, but we don't know side B. We have side C, but we don't know angle C. And we have we don't have angle A, and we have side A. So we don't have a pair that we know both. So we can't use law of sines. So we're going to be forced to use our law of cosines here. And let's think about, well, what sides and angles do we have? Well, this one here, this 8 centimeters, this is, again, side C. This one over here, the 6 centimeters, this is going to be side A. And then finally, this angle over here is angle B. Okay. So what this means is we can use the formula that has little a and little c in it. Let's go up and see which one that is. Little a and little c. That would be this middle one here. This is actually the one that we derived ourselves. Okay. So we'll go ahead and we'll use that one. It's the one that's b squared equals. So we have b squared equals, and remember it should be the sum of the square of the other two sides. Okay, so a squared plus c squared, then minus 2ac, and then multiplied by cosine of angle B. Okay. And this was also the only one in law of cosines that involved the angle B. Okay. All right, next, we know A and C and angle B, so let's plug them in. So we have B squared is equal to 6 squared plus 8 squared minus 2 times 6 times 8 cosine, and angle B was 32 degrees. And if we say add this 6 squared and 8 squared here, and I'm actually also going to take the square root of each side. But if we add that 6 squared and the 8 squared, we'll get 100. And then 2 times 6 times 8, that's 96. So if we just plug this into our calculator here, we'll get our value for B, which is approximately 4.3. And since this is a side length, right, this is in centimeters. And here in a moment, we will talk about maybe how we plug this in our calculator and one other thing. So next, we now have all of the side lengths. Okay? And we do have one of the angles, but we're missing the other two. Okay? Now, we have an option here on which one of these two we want to find first. Okay? And we also actually can use law of sines now. Okay, because we do have a side length and an angle that correspond. So why don't we go ahead and use our law of sines. Let's do that. So we'll have sine of angle A. Actually, I'm just going to write A, sine of A, all over length A, which is 6, and then sine of 32 all over B. Okay. So this side over here on the right, I'm using this because I need it. That was our corresponding side and angle that we know. And this side over here, you might be wondering, well, why did we choose to find angle A first? Why aren't we finding angle C first? And here's the real answer. If we're going to use law of sines is a lot better for finding acute angles than it is for finding obtuse angles. Okay, and this is because when we go to solve for A here, we're going to have A equals sine inverse of something. And when we take sine inverse can only output angles that are between minus 90 degrees and 90 degrees. So obtuse angles, right, are bigger than 90. So sine inverse can't even give you those. And if we choose to use law of sines to find an obtuse angle, we're going to have to be really careful. We're going to have to think about our unit circle, and we'll have to manipulate this answer that we get here a little bit. Okay. So in order to avoid that, we're going to find angle A here first rather than angle C. And you might have one more question. And that is, well, why didn't you write in 4.3 here? Okay. And the answer is, well, B is not equal to 4.3. It's equal to approximately 4.3. So what we're going to actually do is we're going to store this value on our calculator of B. And we'll pull up the calculator here in a minute. Okay. Let's start solving this for that angle A. So I'm going to multiply both sides by 6 here. So we have sine of A is equal to 6 sine of 32 degrees all over B. And then if we were to take sine inverse of each side, we end up with A is equal to sine inverse of 6 sine of 32 degrees all over B. And it ends up that this comes out to about 48 degrees. Okay. And what we're going to end up doing here is I'm going to end up showing you how to plug both of these things into our calculator. Okay, how we got both of these. But for now, let's just do the last step before we jump to the calculator. So we have found side B, angle A, and all we have left is angle C. Okay. And angle C, we don't need to use law of sines or law of cosines for, because we know that angle A plus angle B plus angle C should be 180. So if we're looking for angle C, is what we're going to do here is we're just going to do 180 minus angle A, which we found up here, minus angle B, which is 32. And again, you might be wondering, well, why didn't I write 48 here? Because again, A is not actually equal to 48. It's approximately equal to 48. I'll put in actually the exact value here. I shouldn't actually call it the exact value, but I'm going to put in an unrounded number here in place of A. Okay. All right, so let's go ahead and we'll switch to the calculator and we'll see how we got all three of these numbers here. Let's start off here by calculating B, and that was that square root of 100 minus 96 cosine of 32. And we want to go into mode and make sure we're in degrees here, because this angle was 32 degrees. So mode, And you can see I'm in radians, so I would have wound up getting the wrong answer here, so I'm glad I checked. So now I'm in degrees. And now when I hit answer, we see we get approximately 4.3, right? Well, let's say we plan on using this number again. It's just that when we do use it again, we don't want to type in all these digits, right? We don't want to type in 311308707. And that's okay, because we don't actually need to type it in again like that. Because what we can do is we can hit this store button, STO here. So you'll hit STO, and then after that, you'll select the variable that you want to assign it to. You can see on this calculator here, A, B, C, they're in green, right? And some of your calculators, it might be in yellow. But the point is, if I want to get any of those letters, I just need to hit this alpha button here first. So I'll hit alpha. And then after that, the letter I want to assign to it. And since this was little b was equal to this approximately 4.3 here, I'm just going to use our letter B here. Unfortunately, we don't have lowercase, but I'm going to go ahead and just hit the apps button for B there. And so now whenever I make any calculations involving B, it'll be this B here, the 4.311308707. So like if I wanted to do 2 times B, I can. And your calculator will save this as B until you change it. Okay. So yeah, to override it, you just assign something else to be equal to the value of B. So next, we wanted to compute big A, the angle big A here. Okay. So that was sine inverse of 6 times sine of 32 divided by side length B, which we just stored as B. So I'm going to hit alpha B. And there it is. And so now if I hit enter, okay, we get about 48 if we were to round this to the nearest degree. Now, there's one more calculation we wanted to make, and that's what we wanted to calculate C, angle or side length. Let me look here. It was angle C, not side length C. Okay. And the way that we could calculate that would be doing 180 minus angle A minus angle B. And what we have right here above is angle A. So we could actually store this as A if we wanted to. We could hit store alpha A and then hit enter. And so now we have that stored as A. So we could do 180 minus alpha A minus 32. And this should give us our answer for big C, angle C. And you can see it comes out to about 100 degrees if we were to round to the nearest degree. The last thing I want to say about this is your homework won't require that, you're this careful with the decimal places. But in the future, there will be times where you're trying to be careful with your calculations. And this is how you can do that. This is how you can keep all those, you can keep all that accuracy without having to type in a long mess into your calculator.